Hello and welcome to this screencast on logarithms. Now to start with, what I'm going to do is I'm going to write down a algebraic equation, and so I've got 10 to the power x equals 100. Okay, so here we've got an algebraic of an unknown variable x, and I've got 10 raised to the power x equals 100. Now if we wanted to solve this equation, it's quite easy to see that x would be equal to 2. The reason being is because 10 squared, or 10 raised to the power 2, is equal to 100, and that provides us with the solution to that equation. Okay, but what happens when I have the equation 10 raised to the power x equals 200? Okay, well here we've got a problem because 10 raised to the power 2 is 100, and 10 raised to the power 3 is 1000. So this tells me that it's got a range somewhere between 2 and 3. But how am I going to find out what the value of x is? Now what I could do is do a trial and error. So I could put in, say, value of 2.5 into a calculator, see what that equals to, and then go from there. But that's not good. That's not what we want to do. So what we can do is use what's called a logarithm. Okay, so what I'm going to do is just scroll down a bit. Okay, so I'm going to use what's called a logarithm. That's simply a mathematical function that allows us to solve equations of the form a to the power equals n. So as we saw in the screencast of the exponents, a is a base, x is an exponent, and n is just some number. So if I have a problem of this form, what I can x, the power, is equal to a logarithm, which is written for the base a, and that's a logarithm of n. Okay, I'll explain how to calculate this in a bit. Okay, so if you have an equation of this form, a to the power x equals n, then the solution is x is equal to a logarithm to a base a of the number n. Okay, so if we go back and have a look at our problem here, so we have 10 to the power x is equal to 200. If I was to use a logarithm, so following this definition up here, the power x should equal to log to the base 10 of my number 200. Okay, what I'm going to do now is I'm going to bring in a calculator just to show you how to calculate a logarithm. Okay, so here I've got a calculator, and bear in mind this is a computer calculator. It's not very good. The hand calculators, which you're probably more familiar with, are better. Okay, well, as you can see here, I have a log button. Okay, on a normal calculator, you probably won't see this base 10 bit here. But on a normal calculator, the LOG button is log to the base 10. Okay, and to calculate log to the base 10 of 200 on this calculator, I type 200, and then I click the log button. Okay, and that gives me a result of 2.301. Okay, so using a calculator, I have the result of 2.301. Okay, what if you don't believe me? Okay, how would you know this is a solution? Well, as always with any algebraic solution, we can always go back and check. So if we raise 10 to the power 2.301, okay, I'm just going to bring the calculator back in. What is 10 to the power? So there's a power button on this calculator, and we have the power 2.301. Okay, press the equals key. And we can see here it's 199.986. So we were expecting 200, but we haven't quite got 200. Now the reason for this is the 2.301 was truncated. Okay, so I wrote down 2.301 to 3 decimal places, and when you raise numbers to increased. Okay, so that's close enough. So that's 199.986. So we have 199.986. That's close enough to 200, so that checks, but the 2.301 was indeed the correct solution. Okay, well, if you remember the screencast on exponents, there were 3 laws of exponents. Now, there are also 3 laws of logarithms, which can also help us in dealing with logarithms. Okay, so what I'm going to do is I'm going to write down the 3 laws of logarithms for you right now. Okay, so the first law is if I have a log of a number x, notice I haven't written a base. Okay, so log, I'm going to say a of x plus log a of y Okay. First law states that this can be written as log a of x times y. Okay. A couple of things I want you to notice. The base of the logarithm has to be the same. So whereas in the exponent law exponents the base had to be the same, in logarithms the base has to be the same. Okay. These x and y's are just numbers, so they can be the same if they want. They could be any number, and all you do is when you add logarithms, you multiply. You recall from the laws of exponents, when we multiplied exponents, we added. So it's kind of a reverse. Okay. What happens if we have log to the base a of x divide log? Oh, sorry, not divide. Getting ahead of myself. Okay, log to the base a of x minus log to the base a of y. Well, in this case, we divide x and y. Okay. Okay. So again, this should be remind you of the laws of exponents. Okay, and finally, what if we have log to the base a of x to the power y? Okay. Well, this can be written as y multiplied by log to the base a of x. So whenever you have a power within a logarithm, just bring the power outside and multiply that logarithm by that power. Okay, and these are the three laws logs. Okay, and we could use these laws of logs to calculate a logarithm to any base. So what I'm going to do now is I'm just going to quickly bring in the calculator again. And most scientific calculators can only calculate logs to specific bases. Now this particular one can calculate log to the base 10, log to the base 2, which is useful in computing, and also the natural logarithm, which is base e, which I'm not going to look at in this screencast. Okay, so what if you want a log, say, to the base 4? Okay, well, you can't use any of these three buttons. So what we have to do is use the laws of logarithms to derive what's called the change of base law. If we start with our standard equation, so a to the power x equals n, x is some unknown quantity. I know what a is and I know what n is. Okay, what I'm going to do is I'm going to take log to the base 10 of the left hand side of the equation. Okay, so I've taken log to the base 10 because I know I can calculate log to the base 10 using a calculator. And I'm also, well, because this is an equation, I have to do the same to both sides, so I'm going to take the log to the base 10 of n. Okay, so what I've done is the left side, I've taken the logarithm, and I've done exactly the same to the right. Okay, we're using the third law of logarithms on this left-hand side will give me, if I take the x outside the log and multiply, I have x log 10 of a is equal to log to the base 10 of n. Okay, I want to solve for x, and at the moment x is being multiplied by log to the base 10 of a, so if I divide throughout by log to the base 10 of a, I end up with x log n divided by log to the base 10 of a. Okay, and this will allow us to calculate logarithms to any base. Okay, so another way of writing that is I can say that log of a to the n is the same as saying log to the base 10 of n divided by log to the base 10 of a. Okay, so this log to the base a of n comes from the direct, comes right from up here. Okay, if I was to solve this straightforward using logarithms, I'd have x equals log to the base a of n. Okay, so this is known as the change of base law. Okay, and that allows you to calculate logarithms to any number. Okay, so let's have a look at a couple of examples of using logarithms to solve equations. Okay, so what if I have an equation 2 to the power x equals 32, for example? Okay, so what I have here with x would be equal to log to the base 2 of 32. Okay, so that's using a logarithm. Okay, using the change of base law, we can't calculate, well, on most calculators you can't calculate log to the base 2. What we have here is log to the base 10 of 32 divided by log to the base 10 of 2. So if I bring in the calculator again, I know this particular calculator can calculate log to the base 2, but I'm just going to demonstrate it. So, okay. So 32 log to the base 10 is 1.505. So we'll have on the top 1.505, and on the bottom 2 to the log of 2 to the base 10 is 0.301. So I have 0.301. And if I divide both of these, if I calculate what this is, it's near enough equal to 5. And that's, so the solution to this equation, x is 5, and which could have actually seen if you know your powers of 2's.